Large language models are processing text tokens and image tokens, but digital world is made of bytes. So intelligence in digital world should be in bytes, and it makes intuitive sense to be in bytes, and a lot more data and communication can be done in bytes, and it can generate bytes directly instead of tokens. It can generate images, screens, it can process, it can use your computer, everything in bytes. The problem is there is too many bytes, the sequence length is too large, tokenizers compress that, so we need to overcome that, and that's the next big thing that Grok, XAI, probably OpenAI and Anthropic and other companies are researching. And here you can have unified modality for everything. No separation of text, of video, of images, so you can just have unified. And you can use autoregressive large language models or diffusion models. So this is the next big thing that you can learn and contribute. So the new Grok model, I don't know if it's gonna be Grok 5 or a separate kind of model, some visual model, they call it V7, is going to train on bytes and bits as inputs. This is crazy, so there is no tokenization, it's just bits and bytes. And this is, I'm thinking, the final form of AI. It's not gonna tokenize, it's gonna consume bits and bytes directly and then generate bits directly. It's designed to process raw video and audio bit stream directly. This is what we need. And guys, we should not try to match or invent human intelligence in digital form. I believe there are many different ways to make digital intelligence. So we can do it with bytes, with tokens, with everything. So it makes sense to research it with bytes, because then we don't need any processing and digital world is in bytes. And we as open source, we can do this, and we can do this even faster than XAI because there is more of us. So open source is just not doing these things. That's why we are behind. So my ideas, you can check out my courses, a few hour courses on coding these LLMs. But I'm gonna maybe create this research GitHub repository, make some videos, try to come up with some research questions. So I think open source, we should be at the frontier of science, and we should not wait for these companies to invent these things. And of course, everybody will benefit. Companies will get free research, which is good. Everybody gets free research. That's what open source is for. If this gets done, then there will be big jump in understanding video and image, because there is no tokenization, compression, and all this stuff. So it can also understand emotions in voice and stuff. It can see it as raw data, the way we see and hear it. Autonomous game development, autonomous website development, where agent is coding and then looking at raw bytes, using it like a user, and then giving itself feedback. So right now I'm feeling this is the next big thing. So we have a few next big things. One is FP4 training, that's short term, next big thing. And the other big thing is raw bytes as input, including text, image, and video. And there is 10,000 more image data than text data on the internet, maybe 1,000 to 10,000, and there is 1,000 to 10,000 more video data than image data on the internet. And LLMs and models cannot consume all of the video data yet. And as open source, we should do this at the pace or before the other AI companies. So this could be the base, this V7, for the Grok 4.20, the next model, or Grok 5. I'm guessing that their internal models have different versions than Grok 4, 5. So they have 7 versions here. Or maybe this is Vision 7 version or something, I'm not sure. I'm gonna make this GitHub repository, Bitstream Foundation Models Research. So LLMs and visual language models that take in bits or bytes directly without tokenization. I don't know what I'm gonna do with this GitHub repository. I'm gonna try to maybe read some papers and maybe do some research here. I'm not sure, I'm just gonna create it for now. But this definitely makes sense that we don't tokenize, we stream bits and bytes directly into LLMs or visual language models and models. I clone the repository. I have my small LLM you can check my video, publish your own LLM, and then I'm gonna ask Gemini, I'm gonna give it some research paper about bytes bitstream input and my LLM and ask it what I should change based on the research paper. This is the research paper. It actually changed so little code. It just made token vocabulary 256 bytes and something around that, and that's all it did. Just replaced tokenizer, so it's very little change. So I will pray this works. Let's see. Main issue with bytes is sequences become too long. So instead of one token apple, you have 5 bytes, 5 tokens. Looks like this is actually learning quite well. In the beginning, it was all random characters. After some time, a few minutes, there are some words. And even further, example, complexity and example. So this is actually learning Byte-Level transformer. Just the sequences would be too long. I don't know if they have also some kind of compression, even if they do raw tokens. Maybe there is some kind of grouping of tokens like patches by meta or something, or they go directly into attention mechanism. Also, attention mechanism is also kind of looking and selecting information, paying attention to some information, but the problem with attention mechanism is it scales quadratically and we have huge sequences. So I guess when we solve quadratic scaling of attention mechanism, we will automatically solve the problem of long sequence for bytes. In this case, we should look for solution to quadratic scaling of attention. I'm not sure, maybe Mamba. They have these hybrid architectures with Mamba and attention. But I wonder how XAI did it. I'm gonna try to check the papers. So here is an idea. We process tokens and then we have another small neural network that learns which tokens or which bytes to delete. But somehow through attention mechanism, information from these bytes is kept. Or is it through attention or something else? But whatever, we have dynamic compression of input sequence, so deleting and compressing information. People are relentlessly trying compression algorithms, but yet to no avail. Then we have this idea of Byte Latent Transformer, where you have smaller encoder that's gonna convert a bunch of bytes into vector embedding, and then that's treated as a token in transformer. So this is by Meta. So they create bytes using perplexity, where the model is just confused when it sees next byte, which means that part of data is more complex and requires more compute. So it will then separate that model with that part that's confusing into separate embeddings. So if there is a bunch of bytes that are not confusing, that are easy, then they will all get grouped into a single patch, and vice versa. In the past, the biggest problem with training large LLMs is the feed-forward network, which is huge, and it needs to run on every byte. So that's why tokenization came in. They say here it's not even the problem with attention mechanism, it's problem with the large feed-forward network. That's the computational bottleneck, if the models are large. But this now seems solved by mixture of experts. But during the training, all experts are working anyways when training, so that's still maybe the biggest problem in large language models. I'm surprised that they say that attention mechanism is not the problem if you have bytes, a lot of bytes, but the feed forward, but I guess you keep attention, you keep context window shorter. Also, transformers will allocate same amount of compute to every token, but not every token is equally difficult or unpredictable or difficult to understand. So this method will group bytes and allocate compute based on how difficult or unpredictable bytes are. Here we have a sequence of bytes. So S start better than byte pair encoder BPE, and this local encoder will encode those bytes. You see here we have this higher entropy, but we group these, and lower entropy means they are easier to predict up until here, and then is a bit T is a bit higher entropy because it's a new word, it's a bit harder to predict. But then when you have that new word, it becomes new letter, first letter, it becomes a bit easier. So this could be the second group of the second patch. And then the third patch here, higher entropy. So we have these three patches. And I forgot to say, of course, here we have another patch here. You see the entropy here is high. So wherever entropy crosses this threshold, we get one patch. So entropy-based grouping of bytes into patches via cross-attention. We'll see later how that's done. And then this large latent transformer predicts the next patch. And then unpatching to byte sequence via cross-attention again. So here the first one is disregarded, the first patch. I guess this is to stay within the limits of context window. And then better than byte pair encoder, and then exclamation mark is the last predicted patch. So I just gave to Gemini the whole paper and GitHub repository and my LLM, and I told it to tell me step by step what I should implement to implement it into my LLM. One of the things also I think would happen is as LLM is learning these bytes, it's gonna be less and less surprised by them. So it's gonna start grouping more and more the bytes, and the sequence length will become shorter and shorter, and so it maybe even scales better than tokens. Tokens are fixed always length, fixed information amount. I'll just copy this output explanation by Gemini into Claude the Sonnet. It's better at coding, but Gemini is good at long context, so you can just take everything and plan. So it's already reducing my batch size to 8, max sequence length to 128 patches. So that's still a bunch of bytes, I guess. Number of documents 1000, okay. Patch size 8, fixed patch size for simplicity. Oh hell no. I'm gonna ask Gemini how would I make patch size not fixed. Vocal size 258 for 256 bytes and pad and end of sequence. Although some people are using pad and end of sequence as same token. So we need another model that's gonna predict bytes. It doesn't need to be too powerful. It just needs to provide a reasonable estimate of uncertainty. It's trained separately and frozen before you train the main Byte Latent Transformer. Actually, why not train them together? So as Byte Latent Transformer is learning, the bytes become more predictable. So it's gonna start grouping more and more bytes. Now it's making this Byte-LM. It's a small LLM that's just gonna try to predict next byte and learn entropy. It just needs to be like a little bit. So this is it. This is the train entropy model. It's Byte-LM that's gonna just predict entropy. So I got 1,000 lines of code in my LLM here, which is just 11,000 tokens. So I got 1,200 lines of code, 11,000 tokens, which is not too much actually. It's surprisingly low. I have this README file as a compilation written by Claude for research, for future research question ideas, future research ideas. I'm gonna be checking this. You can also check this in the repository and how to run all of this stuff. So for now, I've just prepared it, put it onto this GitHub page. You can fork, you can start, you can do more research. I'll look into this later as well, probably. Check out my courses if you want to learn to code Qwen 3 from scratch, GPT-5, Llama 4, DeepSeek from scratch. And see you next time, links below. You can also check my videos here. if you're interested. You can learn AI research on my channel.